Okay, in this video we'll show how to implement Newton's divided difference interpolation on a spreadsheet. So let me go ahead and open up my spreadsheet and we'll type in Newton's divided difference interpolation. All right, we'll make that bold and maroon and we're set to go. So let me go back to my document and let's see how this works. We talked about this document, linear interpolation, the first example, and that's not so good because it just looks like straight lines. It's too jagged. Quadratic interpolation, which is the next step. You interpolate using parabolas. And let's see. Let's get to this general form, which is what we're going to implement. Now, what are the characteristics of the general form? We have the function expressed as a polynomial. These coefficients b must be computed by Newton's divided difference, and they multiply by products of monomials. So we're going to need to compute the coefficients b, I'll just call them b, k, and then we're also going to have to compute products of monomials. Now, what do I mean by products of monomials? A monomial is a term like this, x minus x0, or x minus x1, or x minus xn. Notice that each b multiplies a product of these terms. The b1 multiplies x minus x0. b2 multiplies x minus x0 times x minus x1, etc. We'll get to this product of monomials later. First, we want to compute the coefficients bk. The coefficients bk are computed using this formula. And remember, we talked about how this is a divided difference of divided differences. Refer to this table down here. To compute the coefficients, we're going to have to compute this entire table, starting with my values of x and my original function values. I'm going to have to create 1, 2, 3 columns with divided differences, and the first entry in each column is going to give me the coefficient that I need. All right, so let's go ahead and create this table in an Excel spreadsheet. And you'll see that in the spreadsheet, the arrangement of the table is very, very different to the arrangement on the page, which is a good thing. When you can represent your algorithm as a table, that's a good indication that it's possible to implement it on a spreadsheet. All right, so in our case, I'm going to go ahead and start up the spreadsheet. And let's go ahead and see what we need here. We're going to need the first 2 columns. So I'm going to follow his example here. Here he gives a table of velocity versus time. Now, of course, in this instance, the t represents x and the f represents f of x. And in his actual example, he doesn't use all of the data. He only uses the data points here. So I'm going to grab this data, and that's the data I'm going to put in my spreadsheet. And he wants a third-order polynomial that looks like this. All right, so I'm going to go here, grab it, copy it, take it to my spreadsheet, okay, and paste it. And I'll be copying this data. Oops, I think I opened a second spreadsheet. Let's get out of this one, and we'll go to my first one. Here we go. Okay, let's just paste it here. There we go. Okay. All right, so what we want here in this spreadsheet, we're going to want the x values and the f of x values. Those are the first two columns of my table here, x values and f of x values. All right, and I can get these directly off of the data that I grabbed here. Again, remember the t represents x, so I'm going to do 10, 15, 20, 22.5. Those are my x values. And using the arrow to get back here, my f of x values 227.04, 362.78, 517.35, and 602.97. All right, so since I have my x and f of x values, I can go ahead and delete this table. I don't need it anymore. Just hit the delete button, and it's gone. All right. Now, let's see what we need now. We're going to have to create the rest of this table. The first column is for B1, second for B2, third for B3. So I'm going to indicate the columns by the index of B that they correspond to. So I'm going to write up here index K of BK. And this corresponds to K equals 1, K equals 2, K equals 3. And we're going to need 3 because it's a third order polynomial approximation. And let me make these headings in italics. So I'm going to hold down the shift down right arrow, italics. All right, these column headings are not computed numbers, but I'm going to use them in creating the table. All right. Now let's go to this cell here first. What is this value here? Well, we know that these are divided differences. The first divided difference, we saw the function. It looks something like this. In fact, it's exactly like this. It's the difference in function values minus the difference in x's. So I'm going to type equals this function value minus this function value divided by this x value minus this x value. Okay. All right. Now clearly I should be able to fill this down because when I go here, I'm going to take these function values and these x values and so on. So let's go ahead and fill that down. I don't fill down to the last place because there's nothing here to take the difference of. And if you notice in this table, there were only 3 in the second column, and there's only going to be 2 in the third column. All right, so we can fill down here. Now, I could do the same thing for the second and third column. What I want to do is show you how to type this formula using fixed references, and then I can fill right and down and get all the formulas in the column. So again, I emphasize, you could fill this table by typing each formula in the table individually, but I'm going to show you how to do it with fixed references. Okay? It's a little bit more difficult, but once you get the hang of this and you want to make large tables, it's really going to help you. So let's go to this equation here and see what this equation represents in general. All right? So when you take this value here, you're always going to want to depend on the 2 values to the left. All right, I paused for a moment because I was looking for a function that's very useful. If you go to Tools, Detective, Trace Precedence, these are the cells that influence this cell directly. And remember that this cell was the difference between these two divided by the difference between these two. So let me remove that. Tools, detective, remove precedence. If you go down here, you'll see that it depends on these two divided by the difference between these two. So we can see we do want to fill down. Okay, so let me go ahead and tools, detective, remove precedence. Now, suppose I want to move right here. Let's go ahead and do a fill right and see what happens. And let's see what this depends on. All right, now this is clearly not right. We do want the numerator to depend on the two previous divided differences. But the denominator, no, we don't want to go to the B column. We want to remain in the A column. What does that mean? That means if we fix the cell reference, that means if we use fill right, we're going to want to fix the column for the denominator references. There's one additional problem that we have. I'm going to go back here. If I look at the denominator of this term here, this denominator is actually going to be x2 minus x0. If you go up here, I believe you can see it. x2 minus x0. When I go to the third column, it's going to be x3 minus x0. So that's causing a problem. How can I make this formula so that the denominator has x values separated by 2 instead of 1? Well, spreadsheet formulas to the rescue. Notice that in this column, I wanted the denominator values separated by 1. In this column, I want the denominator values separated by 2. But that just happens to be the value in the column heading. Now, I'm going to use a spreadsheet function called offset. So let me take you there. First of all, let me get rid of this. I don't need this anymore. Let me show you the spreadsheet function offset. I know it gives a big, long description, but I have a lot of trouble with these descriptions. I just go down to the example. Here's an example. Offset of A1, semi 2, semi 2 returns the value in cell C3. Why does it return the value in cell C3? Because C3 is 2 rows down and 2 columns over. All right, so that's what this means, that if I take a cell and I offset it by number of rows, number of columns, I can input it using this spreadsheet function offset. Okay. All right, so what do I want to do here? I'm going to retype this formula using these spreadsheet functions. Remember what I want to do. The numerator is fine. The denominator, I'm going to want to fix the column, and I'm also going to want to use offset. All right. So I put a parenthesis. The first term here, in this case it's x1, it's one offset from this value A4. Okay, so this is going to be offset. And it says reference, so the reference is here. I want it offset by 1 row, but remember 1 row was the value here. And it's offset by 0 columns. That's the first term in the denominator. Remember, the denominator is the difference of two x values. So I'm going to want to subtract this one here. All right, now we need to worry about fixing references. Do I want to fix this reference? Well, I need to worry about two things. Do I want to fix the column, and do I want to fix the row? I definitely want to fix the column because the denominator is always referring to x values. So I definitely want to fix the column A. Do I want to fix the row? The answer is no. When I go down, I want to be using this next cell as my baseline. So I do not want to fix the row. I'm done with this reference. Let's move on to C3. Do I want to fix the column? The answer is no. When I move to the next column, I'm going to want to refer to this offset. So I do not want to fix the column. Do I want to fix the row? The answer is yes. I always want to be referring to the offset, which is in this third row here. So I'm going to go here. I want to fix not the column, but the row. So I'm going to hit Shift F4. I'm just going to type a taller sign in here. Okay. What about this reference? Do I want to fix this reference or not? Well, this reference is very similar to this one. It's an X value, so I always want to be in the first column, but I will want to move down as the reference moves down. So this is a dollar sign, and we're done with that. Okay, so let me go ahead. One check of this formula is if I fill down, I should get the same answer when I fill down. So I'm going to select by holding down the Shift and pressing the down arrow, and we'll do Edit, Fill, Down. All right, now let's go ahead and fill right and see if that works. Now remember, in the next column, I'm only going to have 2 entries, so I'm going to select these 2, go to the right, Edit, Fill, Right. Okay, and let's look at these dependencies, which are there left over from before. It's using the correct values in the numerator. It's starting with this X value in the denominator and using an offset of 2. So it looks to me like we've hit pay dirt. So let's go ahead and remove the dependence, detective. And let's go here and see if the same thing works. Tools, detective, trace precedence. And it looks like we're good. The numerator is depending on the right 2 values. The denominator is depending on this X value and an offset of 2. All right, so let's go ahead and remove the precedence. All right. Now I should be able to fill to the right to get the last column here. So I'm just going to hold down the Shift, press the right arrow, Edit, Fill, Right. Okay. And then we have our entire table. All right, let's color this so that we know what's going on here. Our original values were here, so I'm going to put this in yellow. Our calculations were here, so I'm going to put this in gray. Light gray. Now, where are our outputs? Our outputs are the coefficients of B. The coefficients of B, according to this figure, are the entries at the top of each column. All right, so let's do that. At the top of each column, I don't mean these entries here, I mean these entries here, the first entries that are computed, including the original function value. So I'm going to select 1, 2, 3, 4. There should be 4 coefficients because there's a constant coefficient, x to the first, x to the second, x to the third. And let me go ahead and color this. I'm going to color it blue. So those are my outputs. All right. Now, we're ready to check our results by plotting the interpolating function. So here I'm going to plot the interpolating function down here. And this video is already somewhat long, so I'm going to stop here and we'll pick it up in the next video.